Good day, everyone. We are
Jeliza M. Gulandrina,
and Jezraelita G. Sarilibo,
Bachelor of Science in Computer Science students from the Northeastern Mindanao State University, Lianga campus.
Today, we are presenting our undergraduate thesis entitled A Decision Support System for Analyzing Faculty Classroom Observation Ratings Using the Verta Sentiment Analysis version 3.
This is the background of our study. Classroom observation is an important evaluation process used by universities to monitor the quality of teaching. At NIMSU Lianga, classroom observations are conducted by the Assistant Campus Director, Deans, and Department Chairpersons who provide written feedback after observing a class. These comments contain valuable information about teaching strategies, classroom management, and instructional effectiveness. However, manually reviewing and analyzing large volumes of written observations comments is time-consuming and may lead to inconsistent interpretations among evaluators. This is where our study comes in. This is the statement of the problem. Basically, the study identified three problems. First, the absence of an automated sentiment classification system. Second, difficulties in obtaining consistent interpretations of observation feedback due to evaluator subjectivity. And third, the lack of digital platform for generating sentiment-based reports to support institutional decision making.
To address these problems, the study set three specific objectives. First, to train and validate a sentiment analysis model using the Verta V3. Second, to evaluate the model's performance in terms of precision, recall, F1 score, and accuracy. And third, to test the effectiveness of the developed system using the use questionnaire to measure usefulness, ease of use, and is of learning and satisfaction. Our review of related literature covered three key areas. First, on classroom observation feedback in higher education. Studies confirmed that the manual interpretation of written observation comments is inefficient and inconsistent, highlighting the need for automated text analysis tools and academic evaluation systems.
Second, on transformer-based language models, research confirmed that the Verta V3 demonstrates superior capability in understanding complex contextual relationships within text, making it highly suitable for sentiment classification tasks involving nuanced written feedback. Third, on sentiment analysis in educational evaluation, demonstrated that AI-integrated sentiment analysis systems can significantly enhance administrative decision-making in higher education by providing structured, data-driven insights from qualitative feedback. This study adapted and applied developmental research design, integrating natural language processing and machine learning to develop a sentiment analysis system for classroom observation feedback at NIMSU Lianga. The research followed the machine learning development life cycle for model development and the agile software development.
The conceptual framework was illustrated using the input process output model. The input consists of classroom observation feedback, faculty ratings, and faculty profiles. These data undergo the machine learning process, including data gathering, preparation, wrangling, analysis, model training, testing, and deployment. The output is a Verta V3-based sentiment analysis system that automatically classifies observation feedback into positive, neutral, and negative sentiments to support faculty evaluation and academic decision-making.
The class distribution of the CLEN dataset revealed 2,643 unique observations with a slight imbalance, positive at 920 samples of 34.8%, neutral at 877 samples or 33.2%, and negative at 846 samples of 32% after applying easy data augmented. The dataset was expanded to a perfectly balanced corpus of 30,000 total samples, with exactly 10,000 per class, each contributing 33.3%, eliminating classification bias before model training. The Liberta B3 model was trained over 5 epochs using a training set of 21,000 samples and a validation set of 44,500 samples with a batch size of 16 and a constant learning rate of 5E5. Training accuracy improved consistently from 85.91% in Epoch 1 to a final training accuracy of 97.74% by Epoch 5, while validation accuracy improved from 93.71% to a final validation accuracy of 95.89% with both training and validation loss curves consistently decreasing, confirming effective learning without significant overfitting. The confusion metric reveals that the Diverta B3 model accurately classified the majority of negative, neutral, and positive remarks, with high classification rates of 96.33% for negative, 94.73% for neutral, and 96.87% for positive sentiments, demonstrating the model's strong predictive performance across all three sentiment categories.
The system was evaluated by the 8 academic stakeholders at NIMSULENGA using the use questionnaire. Results showed that the usefulness criterion received an overall mean of 4.90, ease of use received 4.86, ease of learning received 4.97, the highest among all criteria, and satisfaction received 4.80. All criteria were consistently interpreted as strongly agree. The computed total grand mean of 4.88 interpreted as strongly agree confirms that the system is effective, user-friendly, easy to learn, and highly satisfactory for its intended users.
Summary, the study developed a decision support system integrated with Diverta V3 to automatically analyze and classify faculty classroom observation feedback at NIMSULENGA. After data cleaning, 2,643 unique observations were obtained and expanded through easy data augmentation to a balanced training corpus of 30,000 samples and 10,000 per sentiment class. The model achieved a training accuracy of 97.74% and a validation accuracy of 95.89% across the 5 epochs, with an overall test accuracy of 95.98 and a macro average F1 score of approximately 0.96 point. The developed system received a total grand mean of 4.88. Strongly agree from 8 academic stakeholders confirming its effectiveness and practical value.
Based on the findings, the study successfully achieved all three objectives. The vertebrate model was effectively trained and validated, demonstrated excellent classification performance.
For user research, we recommend the following. First, expand the dataset by collecting additional classroom observation feedback from different academic years and departments to further improve model generalization. Second, compare the Verta V3 with other transformer models such as Roberta, BERT, and XLM Roberta to expose potential improvements in classification performance. Third, enhance the system by adding multilingual support for Cebuano, Filipino, and mixed language remarks. And fourth, conduct evaluations involving faculty members and other academic personnel to obtain a more comprehensive assessment of the system's institutional impact.